Very good morning, students. Today we are going to discuss about active learning in machine learning. So it's come under Unit 5. So this active learning, when we talk about this, it's a special case of supervised machine learning. It is used to construct a high performance classifier while keeping the size of the training data set to a minimum value. So how we can have this value as a minimum means we can actively selecting the only the valuable data points. That is the key concept behind this active line. So we'll go further. So as I said earlier, it's a special case of supervised machine learning. So here a subset of machine learning we can have an interactive query by the user to label the data so that we can able to get the desired output. Okay, so that is what happens. So to enhance the machine learning model, active learning selects the most informative data points iteratively from an unlabeled data set and request labels for these points. The main idea behind here is it deliberately select the situations where the model is unsure of itself or where it could most benefit from more information. In contrast to conventional or other supervised learning, this method aims to lower the labeling cost and enhance the model's performance with fewer labeled examples. As I said earlier, selectively it is taking the data points or valuable data points alone, it is taking. So we'll see the detailed explanation. So here, how exactly the model is working means to enhance the machine learning model, active learning selects the most informative data points. So for this, we need to do initialization first. So initialization to train an initial machine learning model, start with a small label data set, then model training. So here using the available label data, train the first model. That's what happened. Then uncertainty estimation. To predict the unlabeled data, apply the trained model. Calculate the model's prediction confidence or uncertainty. Margin, variance, and entropy are examples of common metrics. So these are the metrics we need to focus on. So then query technique. Choose the case from the unlabeled pool where the model is unsure or how has low confidence. Depending on the particular active learning algorithm, the query strategy selected may include picking the cases with the highest level of uncertainty, cases close to the decision boundary, or cases where models in an ensemble disagree. So these things we have to focus. Labeling. Ask an oracle, a human annotator, or another source of ground truth labels for labels for the chosen instances. So proper labeling is necessary then, and the recently annotated data to the trained set that we need to add using the revised label data set, retrain the model. So we have to repeat these steps to 6 until a budget is depleted or a performance threshold is reached. So when we get the desired outcome, we can stop. So key concept of active learning. So here we have query strategy, model uncertainty, oracle, stopping conditions. So query strategy, it is important to have a strategy in place for deciding which instances to query for labels. Diverse approaches concentrate on different elements like diversity, uncertainty, or representative sampling. Model uncertainty. Active learning make use of the uncertainty estimates that models frequently provide to pinpoint situations in which the model is unsure of its predictions. Oracle, the organization in charge of the ground truth labeling. In actuality, this might be an outside system or a human annotator. Stopping condition, definitely we need a stopping condition, right? So a model's performance may plateau, a target accuracy may be met, or the iteration of active learning may end when a predetermined number of labeled examples are reached. So when any one of the conditions is, we can say that we need to stop the algorithm. Where should we apply active learning? We have a very small amount or a huge amount of data set. Annotation of the unlabeled data set cost human effort, time, and money. We have access to limited processing power. Example, on a certain planet, there are various fruits of different sizes, 1 to 5. Some of them are poisonous and others don't. How exactly will classify? The only criterion to decide whether the fruit is poisonous or not is its size. So our task is to train a classifier that predicts whether the given fruit is poisonous or not. The only information we have is a fruit with size 1 is not poisonous. A fruit of size 5 is poisonous, and after a particular size, all fruits are poisonous. So you can see the diagram here. So here see, depending on the fruit size, it is categorized, and in a certain condition, definitely it is poisonous. So from 5, above 5, definitely it's poisonous. So we can classify like this. The first approach is to check each and every size of the product, sorry, fruit, which consumes time and resources. The second approach is to apply the binary search and find the transition point, that is based on the boundary. So this approach uses fewer data and gives the small results of a linear approach. So what we can do is we can go for query synthesis and sampling. So query synthesis, generally, this approach is used when we have a very small data set. This approach we choose at any uncertain point from given n-dimensional space. We don't care about the existence of that point. Sampling. In this case, we can definitely use large data sets. In this approach, we split our data set into 3 parts: training part, test set, unlabeled pool. We can have a percentage like 5%, 20%, 70%. The training data set is our initial data set, and it is used to initially train our model. This approach selects valuable or uncertain points from the unlabeled pool. This ensures that all the query can be recognized by human error. So in that, we can do the best classification. So sampling, it is applicable for large data sets. What are the main benefits of active learning? It's reduced labeling cost, enhanced model performance, optimal resource utilization, and adaptability to data distribution. We'll see elaborately. Reduced labeling cost. By reducing the quantity of labeled data needed for training, active learning helps to cut down on labeling expenses. Yeah, definitely. Enhanced model performance. Active learning frequently produces models with higher accuracy and generalization by concentrating on the most instructive examples. Optimal resource utilization. When labeled data acquisition presents a bottleneck, active learning enables a more economical use of resources. Finally, adaptability to data distribution. Because active learning allows the model to concentrate on difficult examples, it works well in a situation where the distribution of data is uneven or even unbalanced. Thank you.